Autodesk's latest webinar with Car Design News. I'm Ewan Say, Associate Editor of Car Design News. As you know, this webinar will focus on Autodesk Alias for Class A modelling. Over the next half hour, we'll be joined by Magenta's Simon Alford as he shows how the software can deliver value-added business and technical benefits, and how it helps OEMs provide seamless end-to-end design development. Simon is Technical Manager for Magenta Solutions and supports the company's diverse automotive customer base, including Jaguar Land Rover, Aston Martin, Bentley Motors, Lotus Cars and McLaren. With over 20 years' experience in automotive design and CAD software development, Simon is trained and consulted in technical surface modelling across transportation design, industrial design, consumer products and F1 industries. He's worked as a digital sculptor at Aston Martin and Jaguar Land Rover and has extensive knowledge of the design development process and surface modelling technologies. Now, before we start, I'd like to invite all of you attending in this webinar to draw up some questions as you listen to this fascinating topic, which Simon will be pleased to answer in the Q&A session, which will follow immediately after his presentation. You can ask these questions by typing them into the box at the bottom right-hand side of your screen. If you experience any technical issues during the session, please type a message detailing the problem into the same box at the bottom of the screen, and our team will do their best to resolve them. We hope you'll find this webinar stimulating and informative, and it's now time to hand over to you, Simon, so you can begin his presentation. Thank you.
Thanks, Ewan. Well, firstly, I'd like to start with saying hello to everybody and thanking you all for attending this webinar. Do you know, this is the first time I presented on Car Design News, so I'm very conscious that I'm perhaps a new name, if not a new face, to people. So what I wanted to do before we dive in and start to look at the topic in detail is I thought I'd spend just a couple of minutes positioning a little bit about myself and my background. So, as Ewan said, my name is Simon Alford, and I'm Technical Manager for Magenta Solutions. My background, though, is actually automotive design. I've spent 15 years working in automotive design, body engineering, and in design Class A for companies globally, consulting for companies globally, a whole proliferation of them really: Aston Martin, Land Rover, Jaguar, Chrysler, Ford, General Motors. And my background is actually as a freelance digital sculptor in Class A, using systems such as, not unsurprisingly, Alias, ICEM-to-Alias, NX, Imageware and CAD's 4X. But really, what does that mean? Well, what it means is that I hope that I can bring to the table a nice eclectic experience of CAD modelling knowledge, and that means things like curve-based surfacing, freeform surfacing, surface solid modelling, feature-based surface modelling and explicit modelling. But I've not only worked in industry, I've actually spent 8 years working in software development for CAD vendors. Most recently, I worked for Siemens PLM Software as product manager for NX automotive design. I've also led competitive benchmarks for design worldwide and consulted in automotive, consumer products and F1. But more recently, I've spent the last 2 years in working for Magenta Solutions in the reseller channel. So what does that really mean? What does it really mean to us? Well, I want to tell you how I feel about my job. I'm really passionate about design. I really enjoy meeting people and working with people. And I guess today this gives me an opportunity to share my ideas and experience with like-minded people. So I'm very lucky. I have a job that I really enjoy. So let's push on and look at this topic in more detail. So when I put this presentation together, I thought really long and hard about what exactly is it that I want the audience to take away. What message do I want you to leave with today? And you know, that really got me thinking about, well, I guess it got me thinking about all the information that's out there about Alias, but also all the misinformation that's out there about Alias for Class A. And so I arrived at this single I guess, single message that I think depicts what I want you to take away from the presentation today. And that is, I want to challenge the misconceptions about the use of Alias for Class A. And I also want to illustrate how Alias can deliver productivity and reuse benefits, and in turn help unite design functions. So in other words, how can we make design go faster using Alias? So the agenda is going to cover some of the challenges we face in automotive design, both internal and external. The advantages of using Alias for Class A, not just technical though, business benefits as well. And then in looking at this holistically, I think we also need to consider some of the challenges in adopting and using Alias for Class A. And again, looking at those misconceptions and potentially some of the barriers that we would face using Alias for Class A. And then I want to summarize, and then we'll take some questions. I have about 30 slides in total, and the presentation will last approximately 30 to 40 minutes. So let's start with looking at these challenges that face design. Well, the external challenges include, in terms of the marketplace, we have a rapidly expanding market. The BRIC countries bring with them a different challenge for design, the different voice of customer requirements that these marketplaces demand. In terms of the customer is changing. They demand high quality niche products, and with that, with the need for an extended product range comes an increased demand for engineering to order. And finally, the business itself is changing. Globalization has had a significant impact on automotive OEMs. We now have globally distributed teams with design functions placed worldwide on different time zones with different influences. So that's the external challenges facing design. But what about internal challenges? Well, I actually believe that I think quality and technology are now on a near virtual level playing field. So this means really that customers are increasingly looking to design to make the difference. And that's increasingly where customers make their decision about what product they will purchase. Well, actually this puts design under tremendous pressure. There's very little margin for error in design. Designers have to explore ideas, they have to iterate themes, and they have to optimize their design. But the challenge is they have to do all of this fast. They also have to do this with respect to external influences, consumer trends, voice of customer requirements, competitive benchmarking, and perceived quality targets. And they have to do this right across design development, from ideation through concept to production. So really the question on every designer's mind is how can they do all of this and still go faster, get product to market quicker? Well, that's what we're going to look at over the course of the next few slides. So let's look at the current landscape in terms of CAD and visualization products that support the design development process. So what I've done here is I've created a rather generic capture of a design development process, something that I'm sure everybody on this call are going to be familiar with. So typically there are three key phases: ideation through concept and onto production design, or Class A as we know it in the industry. And I have here a number of milestones or gateways that are very typical in terms of a development process for automotive. And the overall development process really can be divided into three key stages: the definition of the proportion and stance before a program starts, design finding or theme investigation during the conceptual phase, and through to the maturation of the design into production design and onto surface transfer or surface release. And throughout that process, the whole process is supported by studio engineers with their engineering feasibility, and that moves from coarse through to fine. feasibility. And typically the marketplace looks and feels today. Autodesk Alias is the de facto standard for concept design. And ICEM-to is the legacy solution for Class A. In terms of the visualization pipeline, it's supported by products such as RTT DeltaGen, VRED, BunkSpeed, Showcase, Maya, and 3ds Max. And of course, throughout this process, we also have a studio support in terms of clay and studio engineering, and an optical quality process that tracks the design development process, supported by cubing, feasibility and function cube. So this is very much a typical view on the world as it exists today. So again, the question is, how can we accelerate this process? So how would this look tomorrow if we were to utilize Autodesk products to deliver seamless design development? Well, as I'm going to pitch today in this presentation, we can actually use Alias for concept or creative design and production design. So we get a joined up solution for design surface modeling. Autodesk offers its new acquisition of VRED for a holistic visualization pipeline. In terms of supporting the studio, Autodesk has T-splines and Maya virtual clay tools or subdivisional modeling tools. And all of the data, the 2 and 3D visual assets that are generated during the design process can be captured using Autodesk Vault. And all of that means that we can help reuse geometry within Class A and across design to accelerate the process. So let's look at that in more detail. So what are the business benefits of using Alias for Class A? Well, I think the primary business benefit is improved productivity. And we get that through being able to leverage geometry reuse within Class A. But how do we do that? What does Alias offer us to deliver geometry reuse? Well, at the heart of Alias is as I'm sure a lot of people on this call will be aware of, is the concept of construction history. And construction history in Alias enables us to make changes and see those changes propagate through our model. And effectively, this enables us to reuse geometry within the Alias part file. But whilst this is really well understood and pretty much accepted within the concept modeling domain, actually this is a revolution within the Class A market space. Typically, Class A modelers, when they're presented with change, they have to delete and recreate their geometry. And these workflows are synonymous with the legacy ICEM solution. Not only do we leverage construction history in Alias, but Autodesk have taken these repetitive construction, manual construction techniques and rolled them into automated tools such as Panel Gap, as you see here, which helps optimize and refine design very quickly. Not only does the construction history enable us to effectively replay those tools, it also means that if we make changes to the volume surfaces or the curves that have defined some of these automated tools, everything updates. So this brings with it improved productivity and efficiency. If we were to consider using Alias for Class A, we then actually end up with a joined-up solution from concept through to production. And this would enable us to mature geometry from concept through to production. Again, this helps us remove or reduce this delete and recreate cycle, in this case between concept and production. If we look at let's actually look at the market space as it exists today. So for concept modeling, Autodesk is the de facto standard, and ICEM-to is the legacy solution for production modeling. And in both of these phases, because we're dealing with design, there's a lot of iteration. Change is synonymous with design. The question is, if we were to move to Autodesk for production or Class A modeling, could we help join up these two functions and deliver seamless design development, and in turn reuse geometry to help accelerate the design development process. And that's what I'm going to start to look at in more detail. So with that in mind, what I thought I'd do is start to look at the actual landscape of the tools in terms of usage. So what I have here is a graph that illustrates a typical, much simplified, typical vehicle program timeline. And on the left we have completeness of geometry, and on the right we have a timeline. And as we see today, Alias is the de facto concept tool, and ICEM-Surf is the tool for production design. And really, I've simplified this down through to 3 key gateways or milestones. The start of the program, design freeze, when design has no more invention, or typically when design can no longer drive the aesthetic form, right through to when design hand the release of surface geometry over to engineering or surface transfer. Typically in the design phase, we're going to see changes that are influenced by design. And in the production phase, any changes are typically driven from engineering. So the down spikes you see in this graph for Alias are design changes. But what's most important about this graph is that you'll notice as we move from concept through to production design, we have to really take the geometry and recreate it if we're using ICEM-Surf today as an explicit surface modeler. But actually, ICEM-Surf is not the only solution out there for Class A. There are solutions that enable us to leverage geometry reuse in the form of feature-based modelers. And 2 of those that are recognized are CATIA, ICEM, and Siemens NX. And here you'll notice that actually, because they use features to model their surface data, we can start to leverage geometry reuse, and as a result we can reduce the vehicle timeline. But we still have a problem. We still don't get joined up design between concept and production, and that's evident in this graph. If, however, we consider using Alias for Class A, we then get a more joined up solution. The down spikes are reduced, and the vehicle program timeline can be accelerated further. So I'd like to substantiate this and actually look at what we mean by these different types of solutions. So in terms of the business benefits, designers can easily communicate with digital sculptors if we use a joined up solution between concept and production design. There's no question that when a design moves from concept to production, the designer feels like they're losing control when the data moves to a tool that a designer is not familiar with. So if the designer can interact with the tool, and typically designers are very familiar with Alias, this helps them improve their communication and effectively preserve the design intent, which in turn accelerates the process. Also, if we can leverage Alias across the design development program, what we end up with is effectively a resource pool that we can easily move around. It's flexible, and we can manage more readily, more easily manage program peaks and troughs. Another challenge for managers in design is resource. As we know, the ICEM user base is actually diminishing. It's an aging user base. And Autodesk Alias, on the other hand, is very strong in terms of its resource capabilities. There's a whole pool of postgraduates leaving university every year with extensive Alias knowledge, hungry to be a part of the design process at automotive OEMs. And if we were to join up concept and production design and use a single system, with it comes reduced cost of ownership benefits, such as consolidating training and personnel costs, and also simplifying software maintenance and support. So to now, we focus very much on the business benefits of using Alias for Class A, but what about the technical benefits? Well, I believe that one of the key differentiators for Alias on a technical perspective is its enhanced user interface. And this interaction model, this user interface interaction model, is what differentiates Alias. It enables users to go faster. Typically when software vendors talk about usability, they talk about ease of use and walk-up usability. And I don't think it's any secret that actually Alias has a lot of its tools hidden from the user, but actually this starts to play into the hands of the intermediate and advanced users, because Alias uses a lot of keyboard accelerators. And what do I mean by that? Well, what I mean is Alias enables the user to bring tools to their cursor, and that reduces mouse travel in the scene, and in turn that enables the users to go faster. The user interface is modern and easy to use, and it's very customizable. In fact, no two Alias users tend to have the same interface. And again, construction history supports change propagation, something that I'm going to look at in detail. Here I've got on the graphic, you can see this circular tool called a hotspot, and this is the CV transform tool, the tool that's used tens and hundreds of thousands of times by Class A modelers. And instead of having to visit an area within the UI, by pressing the space bar, this tool comes to the cursor, which is very quick. So let's look in detail at the different types of systems that are out there and where Alias sits. I'm very conscious that these terminologies are used extensively in the industry: explicit modeling, feature-based modeling, constraint-based modeling. So let's look at how they sit with respect to the competitive landscape. So on the one hand, we have the legacy solution for Class A, ICEM-to-Alias, which is an explicit modeler. ICEM is very good at what it does. It's almost exclusively Bezier in terms of the geometry it creates, but it has limited associativity. It's not really a constraint-based modeler, although you can, in Unified Modeler, apply some associativity. Some of the really, I think, the key advantage with ICEM-to-Alias, and I've used ICEM-to-Alias extensively for production surface modeling, is there is no question the high-quality Bezier algorithms are a real value add for ICEM-to-Alias. But on the downside, some of the challenges are that actually managing change in ICEM-to-Alias is time consuming, and we typically enter into these delete and recreate cycles. It's often quicker just to delete geometry and recreate it than it is to try editing what's there. But that actually means we have limited geometry reuse capability in ICEM-to-Alias. So on the other side of the coin are feature-based modelers, such as Dassault Katia ICEM and Siemens NX Shape Studio. And these systems use something called linear timestamp history. Now this is commonplace in parametric solid modeling. And what actually happens is the tools, every time you execute or use a command, that command is saved in a history tree, and it's saved based on time, so it is linear. They're very powerful. You can drive geometry by parametric expressions such as radius and lengths, and associative constraints such as tangency and parallelism. One of the advantages with feature-based systems is they have extensive geometry reuse and support change propagation. And you can do really clever things with knowledge-driven templates, and often they have a joined-up solution with the engineering domain. But what do these features mean for the Class A modeling process? Well, they're a challenge because fundamentally they are a new and different way of working for Class A. This is a paradigm shift for Class A modeling. It requires a different philosophy from the user. It requires upfront planning before you model to understand and to build in the flexibility and freedom to support change. In fact, timestamp history can actually limit the scope of change unless you build in the flexibility. And on top of that, freeform editing can sometimes be limited with feature-based modelers. So where does Alias sit? Well, I believe Alias sits in between these two modeling paradigms, and it actually offers us the best of both worlds of these two types of modeling. So Autodesk Alias doesn't use timestamp history, but it does have this concept called construction history. Now, construction history is not linear. It's not relative to timestamp, but it does enable us to effectively reuse or replay some of the tools that have been used in the creation of geometry. It's also very flexible in the math that it creates. It creates NURBS data and Bezier data, which gives us a flexible solution. So on the positive side, it enables us to reuse geometry, and it actually supports change propagation. But the key, the big difference for me with Alias is that construction history, it's discrete. Users don't need to manage it. It kind of all happens behind the scenes, which makes it flexible and easy to use. And importantly, there are no timestamp order issues. We don't have to manage a history tree as we do in a feature-based modeler. And if at any point in the modeling the construction history becomes prohibitive, it gets in the way, we can simply delete it. It doesn't affect the way the model builds. The model simply becomes explicit. So I guess you can say we do genuinely have the best of both worlds between an explicit modeler and a feature-based modeler. But equally, there are still some issues or challenges with freeform editing being supported with construction history in Alias, just as there are with feature-based modelers. So I think at this point we really should consider what we mean when I say the best of both worlds, Bezier and NURBS hybrid modeling. I think there's a lot of misconception about Alias with respect to NURBS and Bezier. So let's look at those two maths types and what they mean to the geometry that we create. So Bezier is a very easy to control and predictable math. That's why it's very well suited to Class A modeling. However, on the downside, creating multiple surfaces, that you often have to create multiple surfaces to capture complex forms, which means it can be slow. NURBS, on the other hand, is really accurate and flexible and enables us to create complex forms fast because it effectively ties together the single segments of Bezier geometry into a multiple span solution. But on the downside, a challenge is with NURBS is that it can be difficult to control and it can be unpredictable if the math becomes heavy. And I think this simple graph shows quite clearly the two key differences. Bezier on the one hand is easy to control, and NURBS has, because of the flexibility, can make it more difficult to control, but it is very flexible. So what's actually the correct approach for Class A modeling in Alias? Well, I want to dispel myth number one. Alias creates Bezier geometry. And our approach for Class A is that we would use Bezier for the slabs or the blocks, for the surface transitions, for any blends and all gap conditions. In fact, everything that you model in Alias for Class A can be modeled in Bezier. Not only that, we give the user explicit control over the Bezier form, and that comes in the form of U and V control and also the degree. But I would like to position to you a consideration for the use of NURBS in Class A. NURBS, and this is optional, NURBS could be used for design details, building on the Bezier quality from the blocks. It's often, I think for over 10 years, I've failed to understand why the Class A surfacing modeling has failed to leverage NURBS for things like grey zone construction, where accuracy is paramount. So NURBS is ideally suited for what I term auto-creation tools, or tools that really require minimal post-creation editing. Tools such as rolling ball radius, first flange and fillets, panel gaps, where accuracy is absolutely critical. This is an ideal application for NURBS. Of course, the power with Alias with these tools is that because of construction history, if the user subsequently changed the volume surfaces or the curves that have been used to define these conditions, they will update. Anyway, let's look in detail about NURBS geometry and how the settings of NURBS impact or affect the surface quality. I think, as I've said, there is a huge misconception about the fact that NURBS doesn't create high-quality geometry. Well, actually, NURBS will give the user exactly what you ask of it. In this case, what appears to be a seemingly clean and smooth surface on a wheel arch eyebrow, if we actually put curvature needles on this surface to evaluate the quality, we can start to see that the graph is faceted, which is unacceptable for Class A. However, this is exactly what I would expect with a NURBS surface that's generated as degree 3, because a degree 3 NURBS surface dictates that across the segments or the joins, the knots in this surface, in this NURBS surface, we can only ever have curvature match, not curvature flow. So if we consider that same scenario using a degree 5 setting for NURBS, now the result can be completely clean and smooth across the boundary. And actually, Class A. So I think whilst we're tackling this issue of misconceptions, we cannot avoid the obvious question of the cultural challenges that we face deploying Alias into Class A. So let's look at the typical Alias users today in the industry. Alias is used for CAS modeling or computer-aided styling, and a typical user persona for a CAS modeler is somebody who's creative and artistic. In fact, they usually come from an industrial design background. They're industrial design educated. But importantly, the requirements of the CAS modeler are such that they really have to refine the design intent. They have to work with the designer and explore and iterate ideas. And they do still have some constraints. Of course, they have to satisfy studio engineering inputs, but they're very creative. On the other side, in terms of Class A modeling, with ICEM-to the legacy solution, the Class A user looks and feels really quite different to a CAS modeler. In fact, by contrast, a Class A modeler is usually quite a precise and exacting persona. And often they come from a body engineering background or they're body engineering experts. And the requirements on the Class A design is actually now to deliver the design intent. And this means not so much exploring, but more optimizing and refining the design. And they have to do that, importantly, with more constraints than the CAS modeler is used to having. This would include legal, manufacturing, and engineering criteria. And as we know, in the industry today, these two user profiles are often at different perspectives, mean that we kind of get this pseudo wall that exists within design between the two users. So the question I ask myself is, how can we break down this wall? How can we remove barriers within design? And I think this can be achieved by raising awareness of the design requirements, the actual requirements that the users have, and also leveraging a tool that is joined up, that is seamless between concept and Class A. If we were to use Autodesk for Class A as well as concept, I think we can bring these two user personas together and have a more joined up, cohesive solution for design. So if we consider this now, what are actually some of the challenges in training Alias users from ICEM to Alias? Well, I think it's wholly reasonable that we should expect some resistance to change. In fact, as human beings, change is difficult, and a lot of the ICEM-serve users have been using the system for a long, long time. So it's wholly reasonable we should expect them to be resistant to change. But you know, there really is no worry here. Alias uses industry standard freeform workflows. We're not inventing the wheel. We can use the same processes that we do use today for freeform Class A modeling. And that's typically creating surfaces by 4 points, sectioning the geometry with reference to the underlying scan, editing halls first, and then individual CVs to capture subtlety of form, increasing the degree and adding the flexibility to the surface, evaluating the surface for curvature and highlights, and then also finally editing to address any aesthetic and analytic requirements. And as we know, it's very iterative, so often it means reverting back in the process to where we started and going through this cyclical process. And exactly the same is true of Class A modeling in Alias. In fact, if we look at the bigger picture in terms of Alias surface development, the workflow is identical in Alias for Class A. Users typically start by creating the volume surfaces, adding the transition surfaces in terms of blends, adding any details into the body, interior and exterior geometry, such as pockets and cutouts, and then finally blending the model, analyzing the model using real-time diagnostics, both for aesthetic and analytic analysis, and then finally trimming the model and sewing it all together before visualizing and validating it using tools such as Model Check to release to the wider enterprise. So in terms of ICEM training, Magenta Solutions provide an ICEM-to-Alias conversion training. We actually have a proven solution that we've delivered at premium automotive OEMs in the UK. And we've actually just established an approach for ICEM-to-Alias conversion training that helps us ensure success for our customers. And at the root of this solution is the fact that all training should be supported by consultancy or at-elbow support. So Magenta's approach to training ICEM-to-Alias is to suggest a Alias Fundamentals training course, an ICEM-to-Alias course, in combination with advanced training and consultancy at-elbow support. With these mechanisms, we have found that users can reach, ICEM-Surf users can transition to Alias and reach full productivity within 2 to 3 months. There is, however, a risk. If you go for unsupported training, and that means no consultancy, no at-elbow, no follow-up support to training, there is a risk of the training actually failing to reach productivity. And that's illustrated in this graph here. Typically we find with our fast-track approach, so that's fundamentals, advanced and consulting, we can migrate an ICEM-Surf user to Alias productivity within 8 weeks. If that same approach is taken without the support, it's significantly longer. Without the advanced training, sorry, the pink line there. But if it's unsupported, so basically users just come on the training and they don't get at-elbow support, you really are at risk of either making the learning process very protracted, or quite simply never getting there, failing to adopt the tool. And that really is a place where nobody wants to be. So in terms of ICEM-to-Alias training program, I have some exciting news that I really want to share with everybody on this call. Autodesk and Magenta have joined forces to run a special promotion for ICEM-to-Alias training. We're targeting OEM suppliers and professionals, and we're offering a 5-day training course delivered by myself. I've extensive experience in ICEM-Surf and in Alias Automotive. So I'm very well placed to transition users across. And these training courses will be supported by on-site at-elbow consultancy. So if anybody's interested, I'd ask that you register your interest with myself by emailing this address. In terms of Magenta training, the Magenta Academy offers Autodesk certified training, and we use experts conversant with industry practices and procedures. And we cover the following products for Autodesk typically used in the automotive process. But we also offer consulting services in terms of at-elbow support and to accompany our training from concept design through to production design on to visualization. And we cover all sorts of industries. And that's all under the umbrella of the Magenta Academy. So I think the ICEM-to-Alias training is absolutely critical in terms of the transition path, that it happens smoothly and proficiently to get to productivity, or ramp up to productivity as quickly as possible. But actually, one of the key differentiators with Autodesk is that the learning doesn't just happen in the training room. I think it's extremely refreshing, Autodesk's approach to interactive learning. They have an extensive, rich base of learning tools, including WikiHelp, YouTube, and their online documentation. In fact, it's really interesting. If you go onto YouTube and type in Alias, you will get a proliferation. You'll be inundated with videos and that can help you learn Alias. By comparison, the other systems have really very little in the way of online help for ICEM-Surf and NX and CATIA ICEM. And this is a big advantage for Alias. So that brings me to my summary. So I'd ask myself, what are the key advantages of Alias for Class A? Well, I think number one is improved productivity and efficiency. And this is the ability to reuse geometry not just within Class A, not within the Class A processes, which we do get through construction history, but more importantly by using Alias within the Class A domain and for concept modeling, we get this joined up seamless design solution. And how does Alias go faster? Well, as I mentioned, it's the UI accelerators, it's construction history, and it's automated tools. On top of that, we can accelerate design development through this joined up solution. And that enables us to mature the data from concept through to production. We don't have to throw it away as we move the data between concept and production. And it will help us break down barriers within design. Alias is actually proven in terms of delivering quality through best practice. It is a truly flexible hybrid modeler, offering Bezier and NURBS creation to Class A quality. And finally, the training and support offered for a fast-track training program in combination with the WikiHelp and e-learning and YouTube really does make Alias a viable solution, an alternative, a replacement for ICEM-Surf. So with that, I'd like to hand over to the audience and ask if we have any questions.
Thanks, Simon. That was a fascinating presentation there on how Alias can facilitate Class A surfacing. We have a couple of questions here that have come in. Actually, just going back to your conclusion regarding training, one of the questions here is Alias easy to learn for Class A?
Thanks, Ewan. That's a really good question. I think in principle it is. And the reason is that, as I've mentioned, it fundamentally uses the same approach to Class A workflows as users are leveraging today for ICEM-Surf. We're not reinventing the wheel. The tools and the workflows are very, very similar. The benefits come from the construction history and the improved productivity and the ability to make Alias go faster effectively. So that's UI interaction and customization. And also the fact that a real difference for Alias, and people will find this really quite, they'll put a smile on their face when they learn Alias, because the continuity constraints that we can use with construction history means that when we make changes to geometry, you can actually see the cause and effect of change, and that really does help accelerate learning. So fundamentally, I think Alias, whilst it's a different user interface, of course you have to get familiar with that. I would say that there's a certain investment of effort to learn, but once learned, it's very fast and efficient to use.
Thanks, Simon. We've got some feedback well, we've got another question here for you. I'm going to try and make sure I get this across to you clearly. In Alias, it shows tangency or curvature continuity between the surface, but loses continuity in CAD software. Why does this happen?
Oh, that's so. I'm not sure I understand the question, because I'm not sure that how the continuity is lost. If we're talking about data transfer to other systems, then Alias supports a wide variety of file formats for exporting geometry, and there is no reason that any of those formats would lose continuity across surface boundaries. So I think we'd need to take that offline or understand more exactly what the problem is they're experiencing there. That is not a problem that I have ever come across in industry.
Thanks, Simon. We have another, I think it's, again, more feedback on Alias. I'm going to pass this on to you, and we'll see where we go. You might want to comment on this if you can.
Yeah.
The question is asked, or suggested, that after making drafts and skins, etc., for a primary stage during modelling, holes are formed after trimming, which make it difficult to go ahead, even though the user increases accuracy to make the curves again. So I'm assuming some holes are appearing in the model at certain stages. I think I've got that right. So
yeah,
would you like to comment?
Yeah, I think you've done a good job there, Ewan. Right. So again, without the detail, it's hard for me to address this exactly, but it is a very technical question. But fundamentally, in Alias, what I think what's been asked here is the model watertight? In other words, can it be sewn together accurately? And this is all about the user settings and the user tolerances that are applied to geometry. So Alias has a construction tolerance that is applied unanimously across all tools. So there is no tolerance within each tool, but there is a single setting that controls the creation of geometry, the tolerance of the creation of geometry. So if that tolerance is large, so let's say they're using 0.1 of a mil for position, then obviously that's what Alias will build to. So the tighter that tolerance, the more watertight the geometry will be. So again, very hard for me to answer specifically with respect to a particular model, because I don't know the tolerances that are being used. But again, it should not be a problem that users experience if they're setting the right, using the right tolerances.
Yeah, so the guy sending the questions actually said that he has used and adjusted the tolerances.
Okay, it's interesting that.
Sorry, carry on, Simon. Sorry.
No, I think again I would recommend a set and forget tolerance. So in other words, if you adjust tolerances throughout the course of the modelling, then obviously you have applied different tolerances, a hybrid collection of tolerances. And whether it's Alias or any other system, if you do back off tolerances on different commands, then you are going to effectively have issues when you come to sew, because you have a hybrid solution for your tolerance rather than a single unified tolerance applied to the whole model.
Thanks. I mean, I think some of these questions or statements coming in are very specific to certain applications, and I mean, obviously from Magenta's point of view, perhaps these guys ought to contact you guys for some assistance and some consultancy on this.
Yeah.
We have a final question here, Simon. What are the key differentiators for Alias for Class A surfacing?
That's a good question. I think, in summary, I think the biggest differentiator for Alias is its ability to customize the interface and really enable Alias to go faster, to bring the tools to the user's cursor. In combination with construction history and continuity constraints, this really does make Alias a very fast tool for Class A modeling. And actually, what it enables the user to do is to iterate and optimize production design. And as we know, for Class A, this is really important, because what we want to do is achieve the highest possible quality in the shortest possible time frame. And if every time we want to optimize or make small changes, we have to effectively delete or recreate the geometry, that's time consuming. In Alias, that isn't the case. So I would say the answer to your question is the ability to customize the user interface, and to use accelerated workflows and bring the tools to the cursor, to leverage construction history, and to use the automated tools such as panel gap and some of the blending tools to optimize the design. And all of that helps the designers and the digital sculptors really collaborate more easily and preserve the design intent. So I think that's the key differentiator for Alias.
Thanks, Simon. Well, we've had a lot of interest in Alias, and we've obviously had some feedback from current users as well. I mean, they can contact Simon via Magenta if you wish to delve a little deeper into optimizing the system. But with that, we will bring the session to a close. Thank you very much for joining us today. Remember that the webinar will be uploaded into our archives and you've made available to anyone who wishes to view it. You can access it and all the previous webinars under the Process Lab on Cardesign Youth webpage. Thanks again, and please don't forget to join us on the November 14th for our next in series of Autodesk webinars. Thank you very much, Simon, and with
Pleasure.
that we'll close. Thank you.
Thanks.